Okay, today we are going to be reviewing scale factor. This is something that we did in the early fall, and most of it was looking at real life drawings. So, if you look at this picture, it's a picture of a basketball court, and we are going to be looking at the length. So, the length of the side of a scale drawing is 8 centimeters. So A equals 8 centimeters. So we need to find the actual basketball court, length of the basketball court. So if you look over here, 1 centimeter equals 2 meters. And when we talked about scale factor then, we were looking at real life measurement conversions. So if we have something that's 8 centimeters, we need to multiply that by the scale factor, which is 2 meters per 1 centimeter. Find the actual length. Okay, so I can get rid of my measurements, centimeters. Then I'm just left with 8 times 2, which is 16 meters, which is the actual length there. Okay, so that's just an example of some of the problems that we looked at. We looked at paintings and decks and all kinds of things, if you guys remember that. Okay, so when we look at these different cards, they have different figures. So we're going to talk about what scale factor does when it's equal to 1, when the scale factor is more than 1, and when the scale factor is less than 1. So what we're looking at is a transition from A to B. So which one of these cards shows a scale factor of exactly 1? Which one has a scale factor of more than 1? So we multiply by a number greater than 1. And which one of these has a scale factor of less than 1? So exactly 1, a 1-to-1 ratio, should leave us at shapes that are exactly the same. So that's card 8. More than 1, so if we multiply by 2 or 3 or even 1.1, would create a larger image. So that would be card 1. And anything less than 1, you can think of that as a fraction. So if we have half of something or a third of something, it's going to be smaller. And that would be represented by this image right here. Okay, so if we look at this card right here, from A to B, our scale factor is 3. And that makes sense because we have 1 unit here, and this side length is 3 units. Now I'm going to remind you of a word we use. These are corresponding. So when we look from A to B, it represents a corresponding side. So it's kind of in the same position. It's up against the same angles. So this angle is equal to that angle. And then this is a right angle as well as this right here in A. So those sides correspond. So when I go from A to B, I multiply by 3. And you can see that right away. We multiply by 3 to go from A to B. But when we go from B to A, what is our scale factor? Well, you just take the side that you begin with and you're going to divide it by the side you end with. Oh, no, you flip it around. The side that you end with and you divide by the side you began with. So A over B equal to 1 over 3. So our scale factor from B to A is 1/3. And this makes sense because we are getting smaller. So you see that fractional part of B to A getting smaller. Okay, so now we're going to be working on looking at our scale factor from A to B as 1/2. As you guys can see, it's getting smaller. So B divided by A. If we look at the side lengths, B, this side is 2, and A, this side is 4. So we simply divide 2 by 4, we get that scale factor of 1/2. So what if we reversed it? If we're going from B to A, okay, so let's switch it around. So now we're looking at B to A. So that would be an A over B situation. We saw before our A was 4, our B was 2. So our scale factor is 2, in which that makes sense because we're getting larger. So from A to B, we multiply by a fraction, we get smaller. From B to A, we multiply by a whole number, we get larger. Okay, it's asking now what the scale factor is from the original to its copy. So we're no longer being given the scale factor. So we need to first look at corresponding sides. So we see that the right angle is here on the larger, on the original, and the right angle is here on the copy. We have equivalent side lengths. This is an isosceles triangle. So is this. So if we look at corresponding sides, we can go ahead and take this top edge here and this top edge here. Okay, so in the original, we have a side length of 5 units, and in the copy, we have a side length of 1 unit. So our scale factor, the first thing I'm going to look at is, am I getting larger or smaller? So I'm definitely getting smaller, it's obvious. So my scale factor is going to be between 0 and 1. So less than 1, not equal to 1. So I'm going to take the copy side length, and I'm going to divide it by the original side length. That's 1 over 5. Okay, and that is in its lowest terms. We cannot reduce this at all. So 1/5 is going to be our scale factor. Okay, and sometimes we would have to produce a scale factor drawing. So we've got the original here, and we have to make a copy, and we have to use the scale factor of 2. And these are all on the diagonal, but what I do see is I see one of these cutting straight through a unit like that. So I'm just going to start by reproducing that side. So if it cuts through a unit from side to side, if I double that, I'm just going to cut through 2 units. That. All right, and then this side, I'm cutting through 2 units. So I'm going to reproduce that by cutting through 4 units over here. See how well I can do that. There we go. And same at the bottom, cutting through 2 units this way. 1, 2, I'm just going to double that. And then cutting straight through 2 units, and this time I'm going to cut through 4 units. Did mess up my drawing a little bit. I thought I had. So I'm just going to fix that line there. A little bit. And this is cutting through 4 units, just like that, corner to corner. This one was a little cat-a-corner. There we go. And so reproducing an image is just like that. We use software to do that. Okay, so this one is not technically a geometric figure, but it is an image. It looks like the number 9. So we are going to take the copy and produce an original. And so we have a scale factor of 3 over 2. That means from the original to the copy, we've gone from 2 to 3. So every time we see 2 units in the original, we see 3 units in the copy. Since this is greater than 1, I know that the original is going to be smaller than the copy because the copy is larger than the original. So if I'm looking at this, remember the original has 2 units for every copy's 3 units. So this copy right here, the top here, is 3 units across. So I can reduce that. I will know this is 2 units. Again, with the side, it's 3 units. So now I have 2 units. Now the scaled figure, you notice that it's just a smaller or larger drawing than the original. Or in this case, the original is smaller than the copy. Copy is larger than the original since our scale factor is greater than 1. Okay, now you tell me, what is the scale factor in this figure? Convince me. Okay, so this will be part of your exit slip. You're also going to be seeing some figures, and you're going to have to tell me what the scale factor is from the original to the copy, or from the copy to the original. This exit slip must be finished before class, please. Also, I want you to go into and finish that Savas follow-up work from yesterday. Said I was going to give you a little extra time, so you have an extra short video today. And I will see you guys today for class.